everyone, this is a lesson on different homologous series. On our last video we did 3. In this video we're gonna do 3. In grade 12 you are expected to remember 9, so in our next video we'll do the last 3. In this video we're gonna look at haloalkanes, aldehyde and ketones. The haloalkanes are more related to the alkanes, alkanes and alkynes, the single bond, the double bond and the triple bond. The aldehyde and ketones, they are related. They have something, their functional group is similar in some way. I'll show you now. Let's start by looking at the haloalkanes. The haloalkane are the first group. The haloalkane, the word halo is from the halogens, group 7, where you have your fluorine, your chlorine, your bromine and your iodine. Now the general formula for haloalkane, CnH2n plus 1, so and then plus that halogen, the X is for the halogen. So if you have 2 carbons, you'll have C2H, 2 times 2 is 4 plus 1, H5 plus your chlorine, your fluorine, your bromine. Your functional group will be your carbon and your halogen. The X is for the halogen. And then this is the structural formula. This one has 2 carbons, so it's eth. So it will be chloroethane. Chloro from the chlorine. The fluorine will be fluoro. Your chlorine will be chloro. Your bromine will be bromo. And your iodine will be iodo. So the name will start iodo, and then it will depend on the number of carbons that you have. The next one is the aldehydes. The aldehydes, you have carbon, hydrogen and oxygen. So the oxygen will form a double bond with a carbon. So let's look at the functional group. This carbon will form a double bond with the oxygen. The aldehyde and the ketones are closely related. The difference is that with the aldehyde, the double bond of oxygen will be the first carbon. So in organic chemistry, when you say first carbon, we don't necessarily mean at the beginning. It can be at the beginning or at the end. Remember, these are 3-dimensional things. They move. It's not necessarily like when we have drawn it. So your carbon, the first carbon, the carbon that has bonded with another carbon, not with another carbon, with hydrogen, the first carbon bonding with double bond with oxygen, that would be an aldehyde. When it has bonded with, when you look at the functional group, this carbon has bonded with 2 other carbons. It will always be between 2 carbons. The carbon that has bonded with oxygen, that will be a ketone. So when you look at the general formula, is the same. You would not tell from the general formula that this is a ketone or this is an aldehyde. You'll need a structural formula to see that. So the structural formula of you remember this was the functional group, was that part that makes it a aldehyde. So a aldehyde, the structural formula, you see this carbon that has bonded with oxygen, double bond with oxygen, is bonded with another carbon. On the other side is bonded with hydrogen, not another carbon. So that will be a aldehyde. And then the name, the last part of the name, it has an anal. So because it's 2 carbons, ethanal. So the name ends with anal. With a ketone, structural formula, you see that carbon that has bonded with oxygen, it is between 2 other carbons. It's not like this one, that the carbon and it's a hydrogen. It's between 2 other carbons. Then this carbon will be because of 1, 2, 3, propanone. The extra name that you put is ONE. So it's propanone. So when you look at the aldehyde and the ketone, it's the carbon that has bonded with oxygen. You have to look whether it has bonded to 2 other carbons or it has bonded to just 1 carbon. So that will make the difference. This is the end of the lesson. In our next lesson we'll look at the last 3. Thank you for watching.